Counterfeit products are a massive problem in e-commerce today. Studies estimate more than $300 billion are lost globally every year due to counterfeit goods. Amazon alone spends over $1 billion annually fighting these fake listings, and in just 2024, they removed more than 15 million counterfeit products. Many consumers have unknowingly purchased fake items online, so this is not a small issue. Uh, it is a financial problem, a trust problem, and a platform quality problem. So this is exactly the problem our project aims to solve. So hi everyone, this is Counterfeit Guard. Counterfeit Guard is a hybrid AI system for pre-listing counterfeit risk screening. Before the seller publishes the product, the system analyzes the risk uh, and provides an action recommendation, a clear explanation of why that score was assigned. So the goal is to support a moderation decision with signals that are not only accurate but also transparent and explainable. So our system has three layers. The first one is the front end built on React. The second is the back end, which is the fast API for APIs, inference, and the storage. And the third is the machine learning pipeline. So if we look at the high level architecture of the machine learning pipeline, it has three models. First is the structured model for price and seller signals. The second is for title and the description analysis, and the third model is provides us the final risk score. And for storage, we're using the SQLite that includes the analysis, feedback, listing, and our training runs. We've also made an integration with Gemini to provide human readable summaries for the model outcome. So this is the analyze page of our product. So here I can manually enter the listing details, or I can upload a CSV to import in bulk. I'll use a legit example as a demo. So once I've added these details, I can click analyze risk. So this will force our model to make some prediction. This might take some time. And once we have the result, we can see the risk scores and then the probabilities from all the three models we had. The structured model gave a probability of about 2.5%, and the text model gave a probability of 28.5%, and then the fuse model gave a probability of 7.6%. We've also have an action recommendation for which in this case this is approved. So then we have an AI summary of which you can read of why this product was approved, and then some of the signals from our model. For example, our structured model said that the review to sale ratio is 0.31 and the price anomaly is 1.3x the typical brand baseline, and the token Apple contributed this factor, which these different factors led to the product being approved. And then if we go to a different example, for this case I'll use this suspicious example. Once the results are generated, here you can see the risk score is much higher and the action recommended is block. This is happening because of multiple signals such as price anomaly, low seller trust, and a suspicious wording in the listing text, which is also highlighted in this section. So this demonstrates the value of hybrid approach. The structured text signals and the text signals work together to produce a final decision. So that's why we are using three different models. We are using an AI generated summary. So by default, if the Gemini token is not provided, the model fallbacks to a local summary. Now we'll use the third example, which is the bulk import. So you can import thousands of listings at one time. For now, I'll use a smaller example. So this was fairly quick since I only uploaded 6 items. But in case you import, let's say, thousands or 10,000 items, then each of them will be processed by batch. So let's say a batch of 1,000 by 1,000, they'll get uploaded, and you'll see a progress bar here. So let's look around the uploaded. So from the uploaded items, we have the risk scores turned out to be 76. The item is blocked, and here we have some signals you can see. And in case you find that this model predict wrong, you can just select a feedback. You can come to feedback and write some notes and click submit, and then the model learns from it. So now for the history section, we have the search bar, and then we have some filters for brand, category, if you want to select a specific category, and then some actions and filters for risk score. And then our last section is the important section, which is the metric section. This is divided into 2 categories. So firstly, we have the live operational metrics. These reflect the real-time system usage. And then the second, we have the offline validation metrics, which provides the model quality, and they only change when the model is retrained. So if we look around the total analysis, this tells us how many listings have been processed, the average live risk, the average tells us about the average score across all the listings, and then the latest risk shows the most recent results, and 3 feedbacks have been received. And once you provided the feedback, the model learns from it and tries to improve itself. If we go below, then we have more charts. The live action distribution tells us how many listings were approved, reviewed, or are under blocked. And then the live risk bands, they are grouped into low, medium, and high risk ranges. So from 0 to 39, that's the first category, and from 40 to 69, that's the second category, and then the third category is from 70 to 100. So we trained the model on 15,000 dataset, which is also shown here and here as well. And based off the dataset, we can see about nearly 9,000 listings were legit, and then 5,000 of them were counterfeit. And then we have the offline validation metrics. The precision tells us how out of all the listings predicted, how many were actually risky. Recall tells us out of all the true risky listings, how many we successfully detected. And then the F1 score balances the precision and recall into one number. The ROC AUC measures how well the model ranks risk versus the non-risky listings. And then we have the training accuracy and the test accuracy. We also have the SHAP plot that shows which features have the strongest influence on the predictions. So review count has the lowest, and then the seller sale count has the highest impact on the prediction. So we have also plotted the ROC curve, which visualizes the true positive rate versus the false positive rate of the model. And then the calibration curves shows whether the predicted probabilities match actual outcomes. And then lastly, we have the confusion metrics that breaks the prediction into true positives, false positive, true negative, and false negative. So the key point is that these metrics do not change when a single user submits a listing. These validation metrics only updates when the model is retrained. So this distinction is important so that we don't get confused with the actual lives usage metrics. And finally, for the data strategy, it is weakly supervised. We couldn't find a data set for counterfeit, so we used a public listing data combined with synthetic patterns and rule-based labeling for counterfeit risk